All right, part two of day 18. I had to take a break, ran out of time, and was having some issues with our final project. So we're basically going to start all over again. Um, so let's go ahead and I definitely need to look back over this tutorial or introduction for the project, and then we'll get into it.
Using the example code. What you're
So
aiming
from
for,
the very beginning.
this might seem a bit of an odd question, but have you ever been to an art museum and looked at the exhibition and thought to yourself, I think I could probably do this, and don't really understand why it's considered art? Well, this is a piece of art by Goldschmidt and Chiari called Where Should We Go Dancing Tonight? And it's meant to be a piece of concept art. But when the museum cleaners came here at the end of the day and looked at this mess of cigarette butts and shoes and random bottles, they thought it was rubbish and they promptly cleaned everything up. So, this is what the exhibition looked like after the cleaners were done the next day. So, to the museum's horror, their star exhibition gets cleared up and mistaken for rubbish. So I was talking to a friend and I said, well, a lot of these modern art pieces, I could probably do it, right? We could probably get together, put some bottles on the floor, make a mess, call it art. And he told me, actually, no, you can't. And you should read this book called The $12 Million Stuffed Shark. And it talks all about the economics of contemporary art. And it's a fascinating read. I've learned so much more about how contemporary art is priced and why they're priced the way they are. But it also led me to discover some pretty big, shocking discoveries. Like, for example, the art piece that's referred to on the cover of the page is this shark. It's a shark that was fished off of the coast of Australia and then it was preserved in formaldehyde. But it was preserved really badly. Like, they didn't use enough chemicals, and the shark started going a bit green and a bit of gray in other places, and it also started molding. But this moldy green shark was bought for $12 million. And this is not even the craziest piece. So, for example, this diamond encrusted skull was reportedly sold for $50 million. And these butterfly wings, which have been dissected and stuck to a canvas, was sold for 8.5 million. So, who exactly is this crazy man who's creating all of these pieces of art that's fetching these insane valuations? Well, it's a guy called Damien Hirst. And I think out of all his paintings, the craziest ones are the spot paintings because it's literally spots of color that are organized randomly on a page. And check this out, this particular piece was sold for a whopping £1.275 million. So maybe like $1.5 million. It's insane for a painting of dots. But what I thought was even crazier is if you look at this painting, at least it's got quite a few dots, right? You're getting your money's worth of dots. But look at this one. This is the same artist, Damien Hirst, and this painting, I counted, only has 25 spots. And this sold for £500,000. It's not even about the number of spots. So I personally, still, as you can see, can't really work out contemporary art. But what I can work out is how to get Python code to crack Damien Hirst's color palette and use those colors to generate a random canvas of spot paintings that look equally, if not more appealing than some of the original Damien Hirsts. So this is what we're going to be making as our project. And we're going to be using that package Colorgram to get hold of the color palette. And then we're going to use those colors to create our own spot painting that's going to look like this. Firstly, we're going to be using a package called Colorgram. And Colorgram is a library of code written in Python that lets you extract colors from images. So, for example, if you take a look at this picture, once it was run through Colorgram and 10 of the most common colors extracted, you end up with a palette that pretty much looks the same as the colors in the image. This is the example of how you would use this Colorgram package. And in this case, they're extracting 6 colors from an image. So it basically takes 2 inputs, an image and the number of colors. If we go into Google image search and we search for a Hearst spot painting, you can see that there's a lot of spot paintings that this guy created. I want you to pick a painting with a color palette that you like. Maybe something like this, or maybe a bit brighter like this one. But essentially, pick one of these images and then go ahead and download it. So save image. And then you're going to save that image as image.jpg, so JPG. And then go ahead and hit save. Now go.
Wonder if that was why I was having issues the first time. Because I saved as a PNG. Damien Hirst. Dot painting. And honestly, yeah, fine. We can do this one, I suppose. Save image as. I don't want to save it. That's okay. Dot painting dot jpg. Okay, maybe that'll work this time. So let's go in here too. Come on
Go
now.
ahead and create a new PyCharm project. I've called mine Hearst Painting. You can call yours whatever you want. Now we're going to drag our newly downloaded image, image.jpg, into this project folder, Hearst Painting. And it's going to ask you whether if you want to move the file from, in my case, the downloads folder to my Hearst Painting project. So then we're going to agree and click refactor. So now this painting is inside my Hearst Painting project, and I'm ready to go ahead and create a new file called main.py, which is what I'm going to use to extract the colors from this image. Here's a challenge for you. See if you can figure out how to use this package Colorgram using their project description here and using the example code. What you're aiming for is to be able to print out a list of all the colors extracted from the image and each item in the list to be a tuple that you create. So remember previously we saw how the turtle module likes to work with color tuples, which are created with a amount of red, the amount of green, and the amount of blue, all contained inside a tuple. This is the format that you're going to try and get your data into. It might take a little bit of wrangling and a little bit of thought. Pause the video and complete this challenge. Alright, so we know that in
Before she gets into that, let's give this a good old college try. Alright, so do refactor. Oh now. Perform. Okay, let's see. Can we do a. I think we need to pip install Colorgram. Unless Maybe I did this already. No pie environment configuration file. Alright, so let's completely should delete this whole thing. No, can I just blow it away? I'm not seeing it, so let's dot paint project. Alright, there is our Pi environment configuration file. Let's why are you not showing? Hello? Fine, we can guess we gotta try this again. Dots painting JPG. Alright, now let's hope this is the last time. Bada boom. Alright, now let's try and do our pip install. That's it. Well, then let's do this. And then make sure. Alright, yeah, cool. Looks good to me. Alright. So let's start ourselves a main.py. And we can import Colorgram. Alright, so we got that going for us. Colors equal Colorgram.extract dots painting.jpg. I think that may have been my issue. Maybe it just doesn't like PNGs. And let's go with 15. Alright. What happens if I print colors? Unidentified image error. This is really frustrating. I hate when it's a sort of close to 100% accuracy to the results. Okay, cool. But I really like just to make sure. Pretty sure this will not work. It does not. It is still not identifying the image. 30% discount on PyCharm. All proceeds go to Python Software Foundation. Offer ends soon. Sounds pretty cool. I'll check that out later. But first, um, I guess, and let's do nature picture. Sure, this is a nice picture. Any of these are nice pictures. Let's go. Am I going to have to do something? Alright, well at least it's downloading an actual JPEG. Cool. Shout out that website. Okay. Now instead, let's delete. Yep. Then we have to do refactor. And we are gonna go here. Put you there. Yup. And let's try that now. I really should have named that something different. Come on now, rename. There we go. Whoo! Nature. That was almost gonna be painful. Please. Please work. I'm not getting an error, but I'm also not actually getting anything. Hallelujah. farther than I ever got before. Let's colors print. Seems like this isn't very quick. It's taking a bit of time here. But I mean, we are getting. If I make this smaller. Now, how exactly does she want it to print? She wants a list of these tuples. I'm not entirely sure how to get just the tuple, right? Because that's all fine and dandy, but then let's try this. Alright, RGB list equal. Let's just colors list equals. And then we can do colors list dot append color dot. And then we'll print the colors list. Come on now. Maybe a little faster too. Yeah, I don't know how to get it without that RGB at the beginning. Let's see what she has to say.
And complete this challenge. All right, so we know that in order to use external packages, ones that weren't installed with the Python standard library, we have to first install the package. To install a package, we go to our preferences and then we select our project and then we go to our project interpreter. Now we click the plus button and we search for Colorgram, and there it is. Now let's go ahead and install the package, and once that's installed successfully, then we can close all of this and click OK. Now that we've got our package, we can actually import it. So we'll import Colorgram, and we can use the method that's described here called colorgram.extract in order to get a hold of 6 colors. Now, if we want more colors, for example, in this image, there's probably a good 30 colors. So let's go ahead and extract 30 colors from this image. But of course, our image is not called sweetpig.jpg. Ours is actually called image.jpg. So let's go ahead and rename this image so that it matches with our file. And remember that your image has to be at the same level as your main.py for this kind of code to work. So make sure that you've got it inside the Hearst Painting project folder on the same indentation level as main. Now let's go ahead and print out our colors that are generated. And remember that when you hit run, this process might take a little while. And the author of the library says that for a 5x12 by 5x12 image, it takes about 0.6 of a second. Obviously, if the image is larger, it'll probably take a bit longer. Let's go ahead and hit run and see what we get. Once the process is finished, you can see it's created some colors. And these colors are in a list, and it's got some different formats for the color. To understand that, we have to go back to our documentation. You can see that the color that's extracted can either be a RGB color, which is what we're interested in, or an HSL color, which is not quite what we want. So let's go ahead and write a for loop that taps into each of those colors. So for color in colors, let's go ahead and create a new list called RGB colors, and we'll just leave it as an empty list. And then for each of these colors, we're going to add to our RGB colors by appending. And the thing we're going to append is each of these individual color objects, and then we're going to get the RGB value. And once this process is done, then let's go ahead and print our RGB colors. So now you can see we've got a whole bunch of RGB colors with R equals what, G equals what, and B equals what, but this is not quite the format that we needed in order to use it inside the turtle. We actually have to go one step further. We have to create a R, which is from the color dot RGB colors dot R, and then we repeat this process for green and blue. And then we create our
You, I didn't know that you could just access the red value, the green value, and the blue value. That is very handy, but like, I mean, I guess it makes sense. Maybe. How was I supposed to know that that was there? I mean, it, you know, since it is showing up in the IntelliSense, it, we're all learning here, right? Okay, dot append. Uh, do we need to make this a tuple? I think so. Uh, that. I mean, she got us to the finish line, but we crossed it, so cool. Very nice. I was getting stuck hard on that the first time I tried this.
tuple by creating our new color, which is going to be equal to a tuple with a parentheses and then R, G, and B. Finally, we're going to add to our RGB colors by appending this new color. Now let's print our RGB colors. And you can see we've finally got it in the format that we need. A tuple with the R value, G value, and B value that we can use in our project. Now we've managed to get the first part of the problem solved. So we can go ahead and copy this entire list and paste it into our main.py. I recommend actually testing out these colors using the W3 School's RGB tool. Go ahead and paste your color to replace this current tuple here. Make sure that you still got that word RGB there, and then hit enter, and it will insert each of these values into the RG and B. So you can see the first color we got is actually a shade of white, so probably one of the backgrounds. So we can go ahead and delete that one because we're not going to be painting the background in our dot. It's just going to be white. Now let's check the next one. As you can see, the closer the numbers are to 255.
Okay, 23 schools, RGB. This is not the same thing that she has. RGB calculator, excuse me. There we go. Alright, that's nearly black. A nice burnt orange. Like a brown, I suppose. Nice bright orange. Brighter orange. Yeah, that's pretty brown too, but it's got some difference to it. Nice, nice burnt red. That is not very much different, but you know what? You're right. I should delete it, huh? Whatever you say. Another similar orange to what we already have, but it is a fall nature picture, so on an entirely different side note, I'm not even a big Fortnite person, but this Lego, it's a pretty good model. I am inclined to get it if I have the chance. There's a Lego store that's not too far from me. Me and the wife sometimes go over there. You don't get any better deals, but at least you just get to see everything in person. But all right, that's finally a different color than everything else we've got. So um, I'll work with this. This isn't too bad. And since we have this list, I don't think we need to reuse this. And I'm pretty sure that I can just throw all this out. Well, all right, fine. I will comment all of this.
the more likely it is that it's a shade of white. So this one is probably one of the other background colors in this image. So we can delete that one as well. And finally, this last one is probably going to be also quite whitish. And we can probably delete that one too. This one, because of the blue that's 109, I'm gonna be pretty sure that this is actually a real color. And there we go, we get this kind of sand color, which looks very similar to some of these colors that we see on here. So we can presume that the rest of these, because they're sampled by the frequency of occurrence, are probably going to be real colors that we can put into our painting. Let's save this list as our color list, and we can comment out the rest of this code because we don't need to run this computation every single time. We just want to extract the colors, and then you can delete or comment out the Colorgram related code.
I did just realize that she did 30 whole different colors, so I think I should up my game up from what is now 9. So let's do 25. This, we can comment, uncomment all of this, get you running, and I know I did all of that work for nothing. Whoops-a-daisy. Alright, so let's take, oh, actually, we can, yeah, Alright, do we have any white appearing colors? I don't think so. This one's pretty high up there, but I think we're still in the clear. Yeah, that's fine. Maybe not this one. Maybe not this one. Yeah, that's definitely white. Probably this too. Cool. Alright. Thank you, Angela. That was very helpful.
In the next lesson, we're going to be using this color list to create our Hearst painting. So for all of that and more, I'll see you there. Now that we've used Colorgram to extract all of the colors from our image, and we've created a list from that extraction, and we've gotten rid of all the white shades, then we're now ready to go ahead and start using this color list to create our Hearst painting. So you can either delete the rest of the code or leave it commented out, but the goal of the challenge is to use Turtle and those colors that you've just extracted to create a spot painting like this. Here's the requirements of the program. You're going to paint a painting with 10 by 10 rows of spots. So that's going to be 10 along this side and 10 along this side. Each of your dots should be around 20 in size and spaced apart by around 50 paces. So you're going to need to look at the documentation for Turtle to figure out how to draw these dots. You're going to have to figure out how to move your turtle so that it creates this 10 by 10 pattern and paint our 100 dots using the color palette that we generated. This is your chance to shine, and it's time to pause the video and complete the final project.
Okay, let me get back to this turtle documentation. Um, so if we need to do 20 pixel or size 20 dots with a space of 50, we need to do that 10 times. So that should be well, we need to do 70 times 9 and then add on another 20 for the dot. We don't need the more space, so we could technically probably do this 650 by 650. Right, so let's get back in here and just import turtle. And then we're also, well, we know we need to make my screen equals my screen dot exit on click. T, just the one T equals turtle. Yeah, I still need to figure out how to color. Trying to think, what do we want to do first? I know I need to make the screen size 650 by 650, so let's try that first. Screen size. My screen dot size equals, or no, just 700 by 700, right? Screen size. My screen does screen size. Cool. Alright, that's fair. Now we need to, instead of starting here, we need to start 650. I really shouldn't need the calculator for this, but I do, just because I've got so many other things in my head. So uh, we're gonna start turkey.teleport. Um, on the x-axis, we need to go minus 325 and should be minus 325 also, I think. I mean, now we need to figure out how to draw a dot. Okay, well, looky here. There is, in fact, okay, so I think what we can do is um, just to get 10 dots in one x-axis row. Um, for a range of 10, um, turkey dot dot, size of 20, and to import random random dot choice. Uh, but then do I just move 20 or move 50? Turkey dot forward 50. Let's see what we get. An error. Okay. Bad color sequence. as well try pen color. Really don't know why that's not working. Because these do not need to be. Can I just set the fill color to. No, it still does not like that. I don't. I just like to see what she does for the color.
So the first thing we're going to do is we're of course going to need to import our turtle, and I'm going to give it an alias just to make it more clear what it is that I'm referring to. I'm going to create my turtle, which I'll call Tim again, and it's going to be created from the turtle module, and inside there's a turtle class. Now that we have our object created and saved inside Tim, we're ready to go ahead and do some things with this turtle. If you take a look at the documentation for turtle, you can see that instead of just drawing circles or just moving forwards or left or right, you can also draw a dot. Now, a dot takes two parameters, its size and its color. So we mentioned that we were going to draw a 20 size dot, and then we're going to pass in a random color. So let's create our dot. Let's say Tim dot dot, and then let's give it a size of 20, and then let's give it a random color. Now, because we're using the RGB color that has the R, G, and B values between 0 and 255, we first have to get the turtle module to change its color mode to 255. And we saw this in previous lessons already.
Color mode. I must have totally missed that. No worries. No. Is it the turtle that's color mode, or is it the screen that's color mode? I'm frustrated how it says turtle.color mode, but then in the examples it's talking about screen. Is it not? It's not specifically for the module, it's just let's see what sort of error this gives us. This is just when you think you're out of the woods. Alright, well, clearly I'm still doing something wrong.
So now we can go into our color list and pick a random.
Turtle dot color mode. Why is it right there? Well, that is fantastic. We'll need to remember t.pen. Okay. So what I think is we can do half of this, 350, 350, see how that looks. It's still enormous. Why is the screen so large? Yeah, fine. We'll leave this empty and just see what it gives us by default. What if we do 200 by 200? It didn't care. It did not care one bit. Alright, well, okay. Because we need to do a 10 by 10. And then we will, how do we teleport it? X, loc x for location x equals minus 325. I think that'll work. I was totally on the wrong. So we want to go to 325. I'm not entirely sure why. I think there still might be something wrong, but That's why. We did it. We did it. All right. Let's see if she, or I should say how she did things any
Random
differently.
color using the random module. So let's tap into the random module and get hold of the choice method and pass in our color list. So now it's going to choose a random color from that list and then create a dot, hopefully. Now, we don't want our painting to disappear once we hit run, because right now, if I run this code, you can see it paints a dot and then it quickly flashes away. So let's create a new screen object from the turtle module, and the class is called screen. And then we can get our screen to change its behavior by calling exit on click. This way, when we run our code, you can see our dot painted, and then only when we click does it disappear. So we've managed to get our first dot onto the screen. The next step is figuring out how we can get this process repeated. What if we get our Tim to move forwards by, say, 50 paces, and then we draw another dot? So let's put this into a loop. Let's get it to run 10 times. And then let's indent this block so that it goes inside the loop. And now our turtle is going to draw 10 dots. But notice how it goes off the screen and it kind of starts bang in the middle. And there's also other problems, like we're drawing the path as the turtle is traveling. Let's address one thing at a time. Let's try and move our starting dot so it starts somewhere down here. Now, there's quite a few ways of solving this. One way is simply by turning our Tim, the turtle, before we go into the loop and setting its heading so that it points in this direction. You can have a play around with the heading, and through my experimentation or playing around with the code, I've realized that I need to get this heading somewhere between 180 and 270. So what's halfway between 270 and 180? Well, it's going to be 225. So let's change our heading and let's try again. And you can see that our turtle is now moving roughly in the right direction. So we know that each time the turtle moves by 50, so if we want it to start about here-ish, then we need to move it 1, 2, 3, 4, 5 times. So 50 times 5 is 250. So we'll set our heading for Tim, and then we'll get him to move forwards by 250 paces. So that way we get started right over here. Now, at this point, it's still going to be pointing in that direction that we set over here. So we'll have to set the heading back to 0 if we want it to continue in this direction. Now, at this stage, you might realize you need to do a little bit of tweaking. So we could maybe move our turtle forwards a little bit more so that it's Start around here and we get enough space for our dots. But the next important thing we need to solve before we get rid of the lines, because we can still see the path of our turtle, which is really helpful, is we need to figure out how to get the turtle to turn left, move up by 50, turn left again, and then start creating the second row. That means we need to turn Tim so that it faces up, which is a heading of 90, or you could also just turn it left by 90 degrees. And then we're going to get it to move forwards by 50 paces. And then we're going to get it to turn left again. So we'll set the heading to 180, which is facing left. It's through these stepwise changes to your code that you can actually get a good sense of what it's doing, because you can see it drawing and then see if it's doing what you want it to do. Now, we know that we have our for loop, which is able to draw a line of dots going from left to right. Why don't we move our turtle so that it starts out here again, and then it can move along and create another line? So after turning it to the left, we're going to get it to go forwards by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by
So
10
clunky.
times 50 paces. So that's going to be 500. So now the final thing we need to do is to change its heading so that it faces right again. And now we're pretty close. All we need to do is to get this to repeat every single time we draw 10 dots. How can we do that? Well, firstly, this needs to go inside the for loop. Well, let's say that we create a new variable called number of dots and we set it to 100. We're going to use that instead of the range. And we're going to create a range from 1 to the total number of dots we need to create. And then we can replace this underscore with an actual variable that we'll use inside the for loop. So we'll call it dot count, because this is going to represent the current number of dots that have been painted. Now that we've got the dot count, we can then go ahead and use an if statement to check and see if the dot count modulo 10 is equal to 0, then this means that the dot count is either 10 or it's 20, 30, 40, 50, 60, 70, 100. And under those circumstances, we want our Tim to move so that it can go to a new line. So now if I run this, you can see that Tim draws one row of dots and then swings back around, start at the beginning, and draws another row of dots, and then keeps on repeating this until it gets to the point where it's drawn 100 dots. But this is obviously very slow, so we could speed things up a little bit by changing the speed of Tim at the very beginning to fastest. So this way it'll animate a lot quicker, and we can see our dots show up, and it takes a little bit less time to see it in action. Once our painting is completed, you can see there's one other bug. Our final dot is not painted. And this is of course because our range operator goes from 1 to 100, and that means it's only going to run 99 times, because 100 minus 1 is equal to 99. So we can add 1 to this. So once we've changed that, then we manage to get our 100th dot, which of course again triggers a new line. Now, a lot of these lines were really useful when we were trying to visualize how our turtle is moving. But now that we've got our painting in place, we need to try and get rid of these lines. So we know that from the documentation, we can use pen up and pen down. At the very beginning, and the moment where we've created Tim, we can already get the pen to come up so that we don't draw those lines that you see. By drawing dots, we don't actually need the pen to go down. It's just going to leave a dot and then move on. So just by writing pen up and no pen down, we already get our dots being drawn. Now, the very last improvement that I can think of is once our painting is completed, I'd really like to get rid of the shape of the turtle, which in our case is a little arrow. Now, that's really helpful when we're trying to figure out which direction it's facing or how it's moving. But at the very end, we don't really want this. So, again, back to the documentation. How can we get rid of our turtle? Well, there's show turtle and hide turtle. And this is how we make the turtle invisible. It even tells us that you can do this while in the middle of a drawing because hiding the turtle will speed up the drawing observably. So let's go ahead and hide our turtle as well as moving the pen up. And let's re-visualize this. And you can see our dots being drawn without our turtle, and we end up with a beautiful Hearst painting that we've created completely from scratch. Well, maybe with a little bit of help from Damien Hirst's color palette. So I hope you enjoyed this project, and I look forward to seeing you tomorrow. Hey guys, well done on completing day 18. Now, today I want to talk about how, in a lot of ways, even though you don't think of a programmer as somebody who's, a gym buff, but it's actually really similar. Now, hear me out. I know we don't all look like Arnold. I'm sure there are programmers who do. But, in a lot of ways, learning to code and getting buff at the gym is actually really similar. Because if you think about it, you can't do it all in one go. You can't go to the gym and say, you know what, I'm gonna camp out here for like 48 hours. I'm going to use all of the equipment. I'm gonna just keep doing it until I'm completely knackered. 48 hours later, you'll look the same. I promise you, I've tried. But the point is, you gotta keep showing up daily. It's about that it's about the reps basically that you're putting in every single day. That you're going to grow your muscles, you're gonna grow your coding muscles as well, and that way you're gonna consistently improve. That is the important thing, consistency. So don't worry if you've missed a day here or if you haven't been able to do all of the lessons in one go. Just make sure that you keep showing up and you're consistently putting energy behind it. Eventually, you're going to get there. And once you do, show off your coding muscles in the Q&A.
Okay, so that is that is the final project for day 18. That was just about an hour and 20 minutes. The It took me 2 hours just to get through the all the videos for day 18 and working through it, but like it was already an hour and a half of videos just by itself, so like sheesh, day 18 was a beast. And I mean, this turtle module has been a very good learning experience. Reading the documentation and seeing that it's kind of geared towards helping learners. I think somewhere in here it mentioned children, but then it said something about like not just children, but um, yeah, that was something. And it sucks getting stuck, and I really don't want to immediately go for the answer because I want to try it out, but sometimes you just get stuck, or I should say sometimes I just get stuck, and I'll chew on it, I'll try a few different things, and it just doesn't work out, and that's frustrating because of course I want it to work out. easy peasy. Uh, it just, you know, makes sense. But it's part of the process. Uh, keep showing up. We're already almost 20% of the way through the whole course. So, uh, yeah, I'm going to end it there. And we will be back tomorrow for some instances, state, and higher order functions.